In this lesson, you will learn about Amazon Bedrock, a fully managed service in the generative AI layer of AWS. You will learn the fundamental concepts of Bedrock, its capabilities, and how to interact with it through various interfaces, including the Bedrock Playground, AWS CLI, and SDKs. This lesson will show you how to set up model access and use the Bedrock console. In the Bedrock Playground, you will learn about Inference and its role in AI model interactions and practice with prompts and inference parameters. You will complete hands-on exercises to reinforce your understanding, learning how to invoke Bedrock models using CloudShell with the AWS command line interface and Python Boto3. This hands-on experience will help you implement AI services in cloud-based applications. I'm Deniz Yilmaz, an AWS community builder and content creator here at Digital Den Cloud. As an AWS community builder, I'm committed to sharing knowledge and best practices in Amazon Web Services. Feel free to connect me to ask any questions using the details shown on the screen. This lesson is intended for those who are looking to get started with Amazon Bedrock. It's suitable for cloud practitioners, developers, data scientists, and anyone interested in integrating generative AI capabilities using AWS services. By the end of this lesson, you'll be able to understand foundation models and Amazon Bedrock's unified API, set up model access, and explore the Bedrock console. Learn about inference and its role in AI model interactions, experiment with prompts and inference parameters in the Bedrock Playground, and invoke Bedrock models using CloudShell with the AWS CLI and Python Boto3. Amazon Bedrock is a fully managed service that provides access to high-performance foundation models, or FMs, from leading AI startups and Amazon itself, all through a single, unified API. Firstly, for those unfamiliar with foundation models, let me briefly explain what they are at a high level. Foundation models are large-scale machine learning models trained on large amounts of data. They serve as a base that can be adapted for specific tasks, such as natural language processing or image recognition. These models are designed to be highly versatile and capable of handling numerous AI-driven applications. Foundation models can be used for a variety of tasks, including generating human-like text, understanding and analyzing written content, translating between languages, answering questions based on given information, assisting with code writing and debugging, and creating image descriptions or generating images from text prompts. While foundation models offer powerful capabilities, integrating them into applications can be tricky, especially when dealing with multiple models from different providers. Amazon Bedrock addresses this complexity through its single, unified API so you can interact with all the different foundation models using the same interface. This simplifies integrating AI capabilities into your applications because you don't need to learn other ways to interact with each model. Instead, you can use one consistent method to request predictions, generate text, recognize images, and perform other AI tasks. This unified approach simplifies development and integration, making using multiple models within your applications more accessible. To better understand Amazon Bedrock's capabilities, let's compare it to other AI services like OpenAI's GPT. Bedrock offers models from multiple providers, while OpenAI GPT primarily offers its own models. Bedrock seamlessly integrates with other AWS services. Bedrock provides more options for fine-tuning and customizing models to specific needs. Bedrock runs within your AWS environment, offering better data control. And finally, Bedrock includes models optimized for specific tasks like text generation, summarization, and image generation. Amazon Bedrock offers foundation models from various providers, each bringing unique strengths to the platform, opening up a wide array of possibilities for different use cases. The Anthropic Claude model excels at creating original content such as short stories, essays, and blog posts with advanced language understanding and generation capabilities. Bedrock provides tools for building sophisticated virtual assistants. The A121 Jurassic 2 model offers robust natural language understanding and generation capable of understanding requests, breaking down tasks, and engaging in dialogue. Bedrock also enables advanced search functionalities. The Cohere command model is effective for this, with strong semantic understanding and retrieval capabilities for searching through text and image data. Bedrock is also great at text summarization capabilities. Amazon Titan text models are adept at creating concise summaries of long documents and extracting important information quickly. Bedrock extends to visual content creation. The Stability AI Stable Diffusion XL model can create realistic images based on text descriptions, useful for design and advertising. While these powerful capabilities offer many possibilities, Amazon Bedrock also provides built-in responsible AI features known as guardrails. These guardrails help implement safeguards tailored to your application requirements and responsible AI policies, ensuring ethical use and compliance with relevant standards. Now, with a better understanding of Amazon Bedrock's providers and use cases, let's look at a specific application of these capabilities. The following architecture illustrates a cloud-based, personalized workout plan generator powered by generative AI and user-specific data. This solution creates tailored workout plans by conversing with you in natural language and incorporating your individual fitness preferences. Let's take a closer look. The user interface, accessible via a web or mobile app, is where users enter their fitness goals and workout preferences. It serves as the front end, gathering essential information that will be used to generate the personalized workout plan. Amazon API Gateway acts as the entry point for the application, receiving the data from the user interface. It securely routes the user input to the backend for processing. AWS Lambda processes the input data and triggers Amazon Bedrock. It acts as the bridge between the user's data and the AI model, enabling the application to generate a workout plan based on the specific details provided by the user. Within Amazon Bedrock, the request is directed to the Claude model. Claude uses the input data to create a customized workout plan that aligns with the user's unique fitness goals and preferences. Finally, the generated workout plan is saved in Amazon S3, providing a secure and scalable storage solution. Users can access their plans directly from S3. To use Amazon Bedrock Foundation models, you must have the appropriate access, as access isn't granted by default. An IAM user with sufficient permissions must request access to these models through the console. Once access is provided to a model, it is available for all users in their account for the specified region. Please note that different AWS regions may offer different foundation models, with US East 1 typically having access to the full range of models. To request access, go to the Model Access page in the Amazon Bedrock console. Choose to enable all models or enable specific models by selecting the checkboxes next to the models you want to add access to. Then save the changes, which may take several minutes to complete. The access status will then change to access granted. You can also view all available foundation models in the Providers section of the Bedrock console. This section provides detailed information to help you choose the suitable model for your needs. With model access granted, let's experiment with the Bedrock Playground and discover the ways of interacting with the service. Amazon Bedrock offers free playgrounds that allow you to experiment with different prompts and configurations. These playgrounds include the text, chat, and image playgrounds, each tailored to different types of AI interactions. In this context, a prompt is the input or question you provide to the AI model to generate a response. The quality and specificity of your prompt can significantly influence the output. The text playground is ideal for testing and refining text prompts. It provides interactive feedback to adjust your inputs to achieve the desired quality and tone for text generation tasks. The chat playground is designed for conversational AI applications like chatbots. It focuses on generating and maintaining a flow of dialogue, making it suitable for creating dynamic, interactive experiences. And finally, the image playground allows you to create images from text descriptions. While this might not be relevant for all applications, it opens up opportunities for visual enhancements and creative possibilities in various use cases. These playgrounds provide a hands-on way to experiment with Amazon Bedrock's capabilities, helping you understand how different AI models can be configured and fine-tuned to meet diverse needs. Let's start by selecting the text playground. Then, choose Select Model to pick your foundation model. Throughput on demand means you only pay per use with no long-term commitments. A token is a basic unit of text, like a word or part of a word. The model's maximum length or max token settings controls the output's length and detail. A higher limit allows for more elaborate responses, while a lower limit produces shorter, more concise outputs. Let's use a single prompt. Write an inspirational quote about embracing change and new beginnings. After each adjustment, use the brush icon to clear the text and start a new session with your prompt. Set the maximum length to 20 tokens and run your prompt. You will notice the quotes are very short, more like quick phrases and sometimes incomplete. Now increase the maximum length to 200 tokens and rerun the prompt to see a more detailed and impactful quote. In the inference settings, you can control how the model generates responses. Temperature controls creativity. Set it to 0.2 for more predictable, conservative responses, and then increase it to 0.8 for a more creative and varied output. Top K limits the range of word choices. A top K of 50 may be more focused and conventional. Increase it to 400 for unique word choices, producing a potentially more creative quote. Top P determines the breadth of word probabilities considered. Set top 3 to 0.3 for a more predictable output, using only the top 30% of likely words. And then increase the top P to 0.9 for a broader range, allowing for more diverse and unexpected responses. Adjusting these parameters lets you experiment with how creative or structured your quotes are. In the playground, there's also an example section where you can load pre-built prompts, such as a meeting notes summarizer. These examples provide useful starting points and demonstrate how different prompts can be used for various tasks. While the playground is great for experimentation, in practical applications, you will need to invoke Bedrock programmatically. This approach allows you to integrate AI capabilities directly into your applications, automate tasks, and scale the use of AI models across different environments. With AWS, you can invoke models programmatically using the AWS command line interface, AWS software development kits for Python with Boto3, and Amazon SageMaker. These tools provide a streamlined and efficient way to test, deploy, and integrate AI models into your workflows and applications. You might be wondering, what is inference? Inference refers to the process where a trained AI model generates an output based on input data. For example, when you send a text prompt to an AI model, it processes the input and provides a response, like an inspirational quote. Now, to generate text using an AI model through Amazon Bedrock's API, you use what's called an Invoke model request. Here's what you need to know to set this up. You need to specify which AI model you want to use, which is done using a model ID. You can find a model ID in two ways, using the AWS CLI with the List Foundation Models command, or in the Amazon Bedrock console, select a model in the Providers section to see its ID. You then need to specify the request format. The API expects the request and response to be in a specific format. By default, this is JSON. You only need to change this when working with special data types. The body of your request is where you put your input, like a text prompt, and any special instructions for the AI. Different models may need different information here. These inference parameters control how the AI generates its response, which include the maximum response length or how creative the AI should be. Now that you understand the basics, let's look at practical examples. You will start by using the AWS CLI to generate a story with the prompt story about dogs. After that, you will achieve a similar result using Python and Boto3 with the prompt describe the purpose of a Hello World program in one line. In both cases, you will use the AWS CloudShell, a browser-based shell that comes pre-configured with development tools like the AWS CLI, Python, Boto3, AWS SAM, and plenty more. As the AWS CLI is already set up with the necessary credentials, you can quickly execute AWS CLI commands and Python scripts without needing to set up the local environment. You can find Amazon Bedrock Invoke model code examples in the Amazon Bedrock documentation or in the lesson documentation linked in the video description below. This code example will show you how to run inference with the Invoke model API using the CLI. Copy the CLI command to your clipboard and then return to the AWS Management Console and ensure you're in the region where you requested Bedrock access. Click on the CloudShell icon in the top navigation pane. And once CloudShell is ready, paste the command you copied, which will run your Bedrock inference. Let's now review what this command does and how it works. The model ID parameter uses Anthropic Claude version 2 to specify that you're using the Claude v2 model from Anthropic. The body parameter is where you provide your prompt and set some parameters. This is wrapped in a specific format that Claude models require. Your question or prompt goes here. The max tokens to sample is set to 300, which limits the response length. The following parameters ensure that AWS CLI processes your input correctly, which is a technical requirement for sending the correct data type to the API. The end of the command specifies invoke model output.txt, which tells the CLI where to save the AI's response. After running the command, you will find the generated output in this file. You can open the output file using the Vim text editor. Now to exit Vim, press Escape, then type :Q and press Enter. You can also adjust parameters in the CLI command to fine-tune your results. As you did in a text playground, you can modify the prompt, the max tokens to sample, and add additional parameters like top P to influence the length and creativity of the output. After running this command, open the file again to see how your adjustments have affected the output. You have now seen how to interact with the Bedrock API using the AWS CLI, which lets you invoke models, structure commands with various parameters, and save and view outputs. For an even more user-friendly approach, the Bedrock Playground offers an intuitive way to generate API requests. After running a prompt, you can simply click on the ellipsis to view the API request. This feature lets you see how parameters like model ID and temperature are set, helping you understand the configuration behind each request. It also makes it easy to copy and customize the request, allowing you to quickly replicate the interaction in other environments without needing prior coding experience. While the AWS CLI is useful for quick tests and one-off commands, Boto3, AWS SDK for Python, offers a more flexible, programmatic approach that lets you handle multiple requests efficiently, implement complex logic and error handling, and interact seamlessly with other AWS services. Let's explore a practical example using the SDK. You can find code examples for invoking Amazon Bedrock models in multiple programming languages, including Python, Go, and Java, in the AWS SDK Code Examples section of the Amazon Bedrock documentation. Let's use Python with the Anthropic Claude model. Alternatively, you can find this code example in this lesson's documentation. Now that you have the code example, let's set it up in AWS CloudShell. Access CloudShell and create a new Python file using the Vim editor. Once in Vim, press Escape to enter normal mode, then type : set, paste, and press Enter. This is important when pasting code from external sources, such as the following Python example, because it prevents Vim from automatically altering indentation or formatting. Now press I to enter insert mode and paste the Python code you copied. The Python script is now ready in CloudShell, and since CloudShell comes with Boto3 pre-installed, you do not need to run any additional setup commands. The code begins by importing Boto3 for AWS services and JSON for handling JSON data. It then creates a Bedrock runtime client, specifying the AWS region where the Bedrock service is available. The model ID is set to identify which version of Claude to use. You also define a prompt, which is the text you want Claude to respond to. The request is structured with the model's required format, including the API version, maximum token length, and temperature for response creativity, along with your prompt. This step converts the request into JSON format so it can be sent over to the model. The code then sends the request to Claude by calling the invoke model function, which is like submitting a question. And after the model responds, the code extracts the response from JSON and decodes it to get the text answer. Finally, the response text is printed, showing Claude's answer to your prompt. Now save your work and run it. Press Escape to exit insert mode in Vim, then type : WQ and press Enter to save the file and quit Vim. To run the script, simply type python3 bedrock_claude.py. This will invoke the Claude model through Amazon Bedrock, displaying the AI's response to the prompt. Now let's go back into the script to explore how different settings affect the AI's response. Open the file in Vim, press I to enter insert mode, and adjust the max tokens and temperature values. Save the file by pressing Escape, then type :WQ and hit Enter. Now when you run the script again, you will notice that with a higher max tokens, the AI provides a more in-depth answer. And with an increased temperature, the response may be more unique and creative. This Python script performs the same function as the earlier command line example, but offers greater flexibility. It can be easily integrated into larger programs, provides better error handling capabilities, and allows for batch processing or multiple queries. If you would like to see a practical example of integrating Amazon Bedrock directly into your Python code, please check out my GitHub repository here, where you will also learn how to integrate Bedrock into a serverless application. In this setup, a contact form submission on my website triggers a Lambda function which calls the Bedrock API to generate AI responses with Anthropic Claude and send personalized emails through Amazon Simple Email Service. You can also test out the contact form at digitalden.cloud. Let's recap what you learned in this lesson. In this lesson, you explored Amazon Bedrock and its capabilities for integrating foundation models into your applications. You learned about the concepts of foundation models and how Amazon Bedrock simplifies interaction with these models through a unified API, making it easier to deploy AI-driven functionalities like text generation, image creation, and more. You learned about the unique features of Amazon Bedrock, including its integration with AWS services, the variety of model providers available, and the options for fine-tuning and customizing model behavior. In the hands-on sections, you practiced using the Bedrock Playground to test prompts and configure inference parameters, giving you the ability to experiment with model outputs. You also learned how to programmatically invoke models using the AWS CLI and the AWS SDK for Python Boto3 to enable seamless integration into applications for automation and scaling. That now brings me to the end of this lesson on Amazon Bedrock, and so you should now have a better understanding of Bedrock and how to integrate and utilize foundation models in your applications.